Start.
Okay, so welcome to this new session. We are going to go further with the observations and the existence. Let me first repeat a little bit. So we have observation as an interaction between two things, the observed and the observer. For the observation to exist, you assume that the observer exists and the observed. But the existence is an interval, and the observer is also an interval, and the interaction between the two is another interval, which starts later than the existence intervals of both. And then there is the problem that the observation takes much longer than the existence of the observed. Because first you have to exist both, the interaction has to exist, then you have to go through your machine, you have to read the measurement, you have to think about the measurements to get meaning in your brain, you put it in the memory. At that moment, you have observed. The human processes are much smaller than all the natural things happening in existence moments. So the observation interval is probably, I don't know, but it contains at least two, but probably billions and many states of the universe. Many states of the universe have passed. So that means that there is a lot of manifestations of the observed thing, and even mutations probably, which have passed in one observation interval. And what you observe, you think is the first manifestation interval, and you have this whole series of manifestations and even manifestations of mutations. So you have a kind of average in your observation, you have all these things present, but not realized for you. So you see something here, a letter here, and a letter there, and a letter there, and you think that's the book. So it's very partial, and you have a kind of averaging in your observation. So the conclusion was, what exists cannot be observed. You observe something else. What you observe is a super object of many manifestations of things. So the other thing that is what is observed does not exist, because this is a series of existing things, and my existence was from some potential and the process structure. But here there's in the same long string many manifestations, so that is not an existing thing, this is a group of existing things. So for the physicist this is a sort of interesting thing, I guess there should be. You observe something which doesn't exist, which is sort of counterintuitive, because you think that it has to exist before you can observe it. Yes, but it exists many times and even mutates. So the solution for quantum theorists would be to say, okay, let's make a particle a cloud of probabilities. I don't know where it is, I will talk about that in a moment. And in fact, there are many possibilities. Well, in a sense, that could be interpreted as saying that, well, that is every one of the manifestations and the mutations is a possible place for it to be. And they have some probability. So instead of the smearing out or the averaging, you use this as a kind of indeterminate probability. Which is, okay, it's an approximation, which is not so bad, because these things are all below the Planck unit. The Planck unit is the smallest observation period in time, Planck unit of time. Okay, so we have that. Then there is now other effects to study, but first let me introduce the place. I have to go to some possible geometry. And here is my diagram. STs over the UTs, the GTs are the connections here, the STs are the correspondences. So this is the étale thing above the sort of topological structure we can put on this. And now I have a map from ST to UT, and I call this the place map. So the UT of an AT, I call that the place of AT in UT. So you see, I am not embedding the elephant in my geometry, but it has a place in the geometry. And it is above that place. It exists on that place, you could say, but not in it. It's not inside UT. it's a Tao. Of having embedded living things or even structural matter inside an abstract geometry, I don't think that is really pretty sensible. But I think when physicists do it, they sort of do this without saying it. They don't really believe that the elephant is walking around in the relativity manifold or something. They don't consider that anyway. So. But I do. My elephant is up there. Okay, so let's now look at this. We have here a kind of map, a drawing of reality. I have a time t which I draw as a plane. The plane has a lexicographical order. This can be R2 or the complex field 2. It can be n-dimensional vector space. And you have the lexicographical ordering because the coordinates are ordered by C or by R or Q, whatever you take here. It has an order, and you like the words in a dictionary. The first letter first, the second letter, you get this division, and you do that for an n-dimensional vector space, and you have a total order. So there is a total order. Even when C is not an ordered field, you have to be careful, but I'm not going there. So anyway, my time is not it can be any Euclidean line, Euclidean thing, it can be an ordered lexicographical ordered vector space of dimension 5000, I don't care. As long as it's a totally ordered set. Now I have two moments, let's say. I have the UT, I draw it as a little cube. So this is the state of the universe at that, of course this is only a picture. And I have the ST above it. And here the same with the T prime. I have the place of this is my elephant. This is the place of the elephant. Okay, now I have the change for the elephant from T to T prime. So this is my changed elephant, a manifestation, maybe without mutation, let's say. Then it has a place, which is this one. The place of the elephant is this. But I also have the other place here, and this is the map for the G from UT to UT prime. So this is the geometric or the topological kind of map. So I have this place here which maps to that place. So this is the image of the place of the elephant here. This is the place of the elephant at T prime. And they are different. But if they are equal, if the place of AT prime is the image of the place of AT. So if the place of my elephant in T is mapped by G to the place of the elephant at T prime, then I say it's immobile. Immobile. If this happens at every moment here, it's sort of in some interval, then it's immobile in the interval. And it can be in an existence interval, then it doesn't move in that existence. Maybe something will move, but anyway, let's say we can characterize immobility. If this is different, then there is movement. This place maps to another place than this place. So the elephant, in our interpretation, the change we see is from this place in that moment to that place. We don't see it here, if you see the change. We don't see it here even, we see it much later. Observe. But at least that is what we try to observe then. Okay? So this is observed later. At least an observer's interval for these things. The elephant, and we see it like a film, we see the movement, which looks like continuous, but it's of course very discrete. Every step, every change is in a small existence moment, which we see in average. And I mean, it's known that if you take 12 pictures and you make a film, 12 pictures in a second is more or less continuous. You see it as a continuous movement. So that's what we see. And we see a movement which does not exist. A movement is an illusion. But there are different pictures, if you want, of the place. And the thing, you don't see the place if the thing is not there. But you see it there, and then you see it there, and you think that there was a place that it moved from. So, as I said, assumption that there is some geometry topology or non-commutative topology on UT is completely ad hoc. In a sense, the process is the essential thing in time, and the space does not really exist. The places do not exist. But if the thing, you see, observe a thing, and you think it is there, it is not there, it is spread out. But you think there is a place, and that is the mistake in embedding the elephant in the geometry. You think there is a place. There is not. But what do you have? You have for every existence interval, you have a manifestation, A at I1, A at IT. These are the intervals. These are manifestations of A. There may be some mutations later, let's not care for the moment. Now, what I observe is some observe of A, some observation interval. You see all these manifestations as one thing. And what you then do with the places, you sort of do the same thing. You have this kind of averaging trick like for the observation. But we have real places for the AI1. So that is on the interval I1. And you have a T here. Let's say T. There is a place for a T. For every T in the existence interval, there is a place, and that is a real place. I mean, when we do the definition of the thing, geometry, topology, whatever, it is a set, and it is at least a subset, let's say. And it has some geometric structure, topological or non-commutative, whatever, so it has some extra things, but it is really a subset of the state. You can call that a place if you like. And then with the extra properties, it's a geometric place, a topological place, or non-commutative topological. And then what? You have down the sequence of all these things. And so you have at each moment a place. So I will draw it, I will try to make a drawing. I1, let's say. And I have a place here, and I have a place here, and I have a place here, and I have a place here. So, these are the moments, T, T prime, T double, whatever. Some moments, and you have a place in the UT. These are all in the UT. So you can see there is a series of places in the UT, and they are connected by the GTs. If there is immobility, but otherwise there is mobility. So this is not necessarily a chain or a series for a GT. Because you can have movement, it changes. But you have at every moment a place. So what to do, you can call this chain of places the dynamic place. You can do this as a product, you can take the product of these things in some product space if you like. You can do that, but let's not do it. So the chain, I don't call it a string, because then you think it's connected by the G's. Chain of places. Is the dynamic place of the first manifestation, AI1. AI1 is the manifestation of A at I1. So now we have an existing object. If it's existing, then this is called is a dynamic existing place. A dynamic place. And you can view that if you want to be more mathematical, you can view it in the product of the UTs. You can view it in that, and then you can define the existence topology, dynamic existence topology, and now it becomes more formal if you want. You can study that. And for that I can refer to another book of mine, Virtual Topology. And functor geometry. And I have in there, in this book, which is published in Marcel Dekker Publishing Company, in this book I have the definition of a DNT, dynamical, non-commutative if you like, topology. The non-commutative is very interesting also for physical applications, but I usually don't expand that in such lectures because it becomes then technical and too specialized maybe. But if you know topology, then it's already fantastic. Then you have dynamical topology there's some new notions there. Okay, so now I have the geometry, and you see this geometry I obtain from the very ad hoc definitions I could take in UT. I took the minimal one. Both relativity theory, both quantum theory, and any theory in physics has much more assumptions than that. So that's a minimal model. And we have something like a real place in some product space, because we take an average when you observe, and it is smeared out over the product. That's the more correct way to handle it. So instead of doing a cloud of probabilities, and if I get to another session, I will explain that probability does not apply to reality, because probability is depending on unbiased test. Probability theory is correct, but the application to reality sort of fails. And that's what quantum theorists willingly ignore, I think. But anyway, whatever, it's an approximation again. But here we have no approximation. We can, if you accept that there is a place map, of course to observe that is impossible because it's in a state. But theoretically, there is a place, a dynamic place associated to this, and you can study to some extent the changes, but only via observations. So it will be the same problem as with the existence and with the observing. You have a kind of smearing out over this product, over the interval. So my elephant is smeared out over the interval, first in the existence, and okay, so we have to live with that. We can never know, I am sure, we can never know something in the states. That's why I said taking a geometry or whatever is sort of ad hoc, dangerous, and I took the minimal assumption I can work with. So I do the minimal error. But it's interesting that there is a kind of mathematics you can develop in this new kind of mathematics, these kind of dynamic things. In this DNT theory in that book, I discover a very interesting thing which is called observed truth. The philosophers can think about this. I did it like myself also. Observed truth. I can say in words what that means. It comes from the dynamic aspects of the places and so on. But an observed truth is something, a statement which cannot be proved, but cannot be contradicted. So we have this in mathematics, this incompleteness by Gödel, that there are statements that you can neither prove nor disprove. Fine. Neither prove nor disprove. But that's an observed truth, because if you cannot contradict it, well, you can accept it as true, because it's no contradiction. It's free to accept, let's say. It's free to accept. And where I discovered that, I have this non-commutative topology. And the non-commutative topology has a commutative shadow. There's a commutative shadow of that. And I wanted to prove that the commutative shadow, which is the observed reality, if you like, is also a dynamical topology. So the commutative shadow, this is for the specialists of DNT, DNT. And I could not prove it, but I can. You can prove that it cannot be contradicted. Prove that. Prove that it cannot. You have a proof that it. You have a proof. You cannot prove it, but you can prove that it cannot be contradicted. That's stronger, because you say it cannot be contradicted. You don't know the proof. So that's an observed truth. Okay, that's for the more specialists. So I have a little bit more time, about 10 minutes perhaps, is that true? No? For some dark things. There are many dark things. Oh no, first let me say something about the Big Bang. Some consequences for some paradigm shifts from the things that we have already done. So what about the Big Bang? So for me, everything is a process. So if there is a Big Bang, it's also a process. But is there a Big Bang? Perhaps. We'll see. There are no singularities. Let's say that. No singularities in nature. Nothing goes to infinite. Nothing goes to infinite in nature. But in the model, of course, in the model, yes. But I will say a few more words about that too. Now, the Big Bang is supposed to be an explosion. Big Bang, an explosion, question mark, in a point, 3 question marks, of an infinite amount of energy, or of infinite or very big, let's say. I always say an infinitesimal approximation of infinite. That's sort of pun intended. Infinite amount of energy or matter or whatever you like to be exploding. So an explosion, I think this comes from having some idea about volcanoes exploding or something, or stars exploding. In a point, well, if it's not a point, then they have to say in what place, so they say a point, but a point has 0 size, there is nothing in a point. There is nothing in a point, so that is certainly wrong. Explosion, infinite amount, I don't think so. Infinite does not exist in the reality. So what is it? Well, from my model, the Big Bang only happens if there is a beginning of time. If there is a beginning, maybe not of time, but of the universe. Could be that time continued long before, but there was no universe, so okay, sort of emptiness. But okay, the beginning. So there is a T0, and in the void, the void is where nothing exists. From T0, there are many processes of potentials. So the void is not empty, and now quantum theorists have also discovered that, and even people talk about virtual particles, which is nice, but they are not particles, why should they be virtual? And then the antimatter-matter things. Well, anyway, all these things will be discussed eventually later when we do all the paradigms. But there are processes of potential. So at some moment, things begin to exist. So let's say at T1, the first moment that things begin to exist, many things begin to exist. So many in the universe measurings, these are billions to the power of billions, I mean incredibly many. So what is the Big Bang? The Big Bang, a big exodus from void. So it's a process. It's a process of beginning to exist for many things, and they form gases and so on, and then the physicist can approximate the Big Bang to a certain a fraction of a nanosecond, but not to the Big Bang itself, because it's so-called similarity. No, not because it's a similarity, but if you have something, if you let t goes to 0 in formula with t in the denominator, you have some formula, t is in the denominator, the constant of Planck, there is the c is there too. So then what happens is, first, t is smaller than the Planck unit. The Planck unit is defined in the actual physics, but in my theory, it is just the length, the minimal length of an observation interval. So the Planck unit is not a number, but the Planck interval, unit interval, I can say. So I don't want to call it the VO unit or something. Let's say it's the Planck unit interval. Below that, no observation. So you lose the observations. So that's what they do with the Big Bang. They lose observations, they stop talking. But there's another one. Secondly, t is smaller than the, let's call it the Planck existing interval. Planck is not really involved. There is a minimal existing interval. Below that, no existing. So you're in the void. And then the whole physics breaks down. That's what happens. You come too close to the beginning, below this Planck existing interval. There is nothing existing, and it's all processes. So all short interval processes. Yeah. Okay. So that's the Big Bang. A big exodus, and the thing is processes. What is there before the Big Bang? Well, if you start with time at that moment, then there is nothing before the Big Bang. But if you think in my version, processes, then there can be processes, many processes before the Big Bang. It could even be that at some moment everything was existing already, vanished and came back. Some sort of like mutations on the universe level. So that's possible. So this, not even the shrinking. If there's a theory that you extend, you grow, and then you restrict, you shrink, and you go back to the situation of the Big Bang, you explode again. But to me, everything is more smooth. Everything is a process, and okay, there is a big exodus. By the way, this Big Bang the big exodus is continuing. It is an ongoing creation. There are still things beginning to, some physicists see particles popping up and vanishing. Okay, fine, it's the ongoing creation. So far away, we see maybe some superstars or some supernovas. Some of them can be just big exoduses. So I will have to conclude, but I will give a short survey of some other things. So dark interactions, they appear very natural in the model. Dark influences, not interactions, but something else, or not realized interactions. Then observing the cause after consequence. So, but it's not retro action. You observe it afterwards, but it starts to begin in a moment before. I mean, the interval is like this, and the other one is like that, maybe inside it, or longer. So this is the interval for the cause, let's say, and this is the interval for the consequence. So you can observe the consequence before you observe the cause, because the cause takes longer to end but started earlier. And this is before that. So the cause is before the consequence, but what you see first observed. Because you can start here observing, and here you have to wait until it exists to start, and so on. So this very easy explanation with my model to explain that some experiments in quantum theory, which claim to prove that the future acts before the past. It's wrong. It's just because you observe it later, but it started before, in the moment. Cause, by definition of cause for me, is starting before the consequence. And then there's a lot of interactions. And there will be other problems, because I will have organic causality, and I will stop here. So the thing is that there is observed, existing, and reality. So these dark things I will talk about in other sessions. For the conclusion of today, let me just say that there is reality, existing reality. This is inside here, and there is observed reality. And this is a deformation. Observed reality is not inside reality. Well, you can say it's inside our mind. That is more correct. Almost. Well, you can discuss that. But there's three things. The level here is moments. The level here is existence interval. And here, observation interval, which is not observing the existence interval. This observing is not really observing the existence, but some super things. So this is the situation which I explain completely in the model. And I think it's very logical and plausible. And using not deep mathematics, I can explain more about the non-commutative places and so on, but that's not essential. This is essential. So here we have the three things. Existing reality can be seen as inside reality. There is no interaction with us. But once we begin to mingle into the picture, well, we deform it. So this observed reality, there's a deformation here. And in fact, the deformation goes from observed to there, which is strange, but it's a matter of definition. There's the deformation. Here are the Trinity, the Holy Trinity of reality. And the void is everywhere. The void is not in some place, the void is everywhere. And the matter is over it, not in it. It's over it. The place is there, but the thing is not there. I mean, that's, I think, very interesting that we avoid putting matter in the geometrical objects. So that has a price, that the void is everywhere and there is nothing existing in it, and there are no places, and there's no distance in the void, there is no speed, but there is all these processes interacting. So that's the cooking of the void. So sorry, I'm a bit late, but